1.
Listen up, y'all, 'cause this is it. The beat that I'm banging is Cell-a-licious. Cells have got a definition, they're made up of membranes. But phospholipids and proteins are what make up the membrane. Smooth mosaic is the surface that's made of small pieces, and proteins in the framework of the phospholipids are diverse. And you'll see them drifting all up in the membranes, and the fatty acid tails have double bonds that keep the phospholipids from packing real close so they won't be solid. Cell-a-licious. It's hot, hot, Cell-a-licious. I put those cells in the spot, Cell-a-licious. 'Cause I know all the parts they got, Cell-a-licious. Try me. Steroids in the cell. Steroids in the cell. Steroids in the cell. Cell. Steroids in the cell that are called cholesterol. Keep the membrane fluid at low temps, and when the temps get warm, they stabilize the membrane. And the proteins in the membrane have lots of functions. Here's one. Plasma membrane proteins form junctions between cells. And here's another function, carbohydrates. On the surface of the membrane act like ID tags for cell recognition. Cell-a-licious. It's hot, hot, Cell-a-licious. I put those cells in spot, Cell-a-licious. 'Cause I know all the parts they got, Cell-a-licious. Hold up. Check it out. Semi-permeability, let some substances pass more easily through the membrane. Non-polar hydrophobic molecules are easy, but polar molecules and ions can't cross easily. O to the S to the MOSIS osmosis. O to the S to the MOSIS osmosis. D to the I to the FFUSION to the D to the I to the FFUSION. When the particles spread out evenly in available space, it's called diffusion. They're moving from more concentrated to less concentrated, and this requires no work. The molecules move through phospholipids, and the concentration gradient measures how the concentration of something changes from one place to another. And then there's osmosis, where the water molecules diffuse across the membrane because of a difference in concentration on the two sides of the membrane, so the water moves to the side where the concentration is higher. Facilitated diffusion is when transport proteins let substances move down their concentration gradient, but they don't need no energy. Inactive transport is when cells use energy and do the opposite. Yeah, the cells use energy to move the solute against its concentration gradient. The solute moves across the membrane to the side that's more concentrated, and it gets its energy from ATP. And in this process, there's solute binding, phosphorylation, transport, and protein reversion. And did I forget to mention, in the phospholipid bilayer, the heads love water, but the tails hate water. Yeah, that's bio. V to the I to the OLOGY.